Alright, last time we were together we went ahead and took a look at critical path analysis. Today we're going to go ahead and take a look at what's called backflow analysis. So this is backflow. Okay. We're going to use the same example we used for critical path analysis. We're just going to apply a separate method. So you can see this is the same graph that we worked with on Monday. Alright. The way backflow works is we're looking at days to completion, if that makes sense. So our goal here is to end at 0 days until completion. And now we're going to work our way back, going against the flow of the arrows, right? So if I go back here, task H must occur at least 8 days before completion, right? Task J here must be completed 3 days before completion, right? We keep moving backwards, right? Task I here, 3 plus 2, must be done 5 days till completion, right? Same thing here with F, 5 plus 2. This must be done 7 days prior to completion. Here, task G. Now, task G is the first time we have 2 coming together, right? So I've got 8 plus 5, which is 13, and we have 7 plus 5, which is 12. In this case, as we work backwards, we're always going to take the higher number. So in this case, G must be done 13 days prior to completion in order to get the rest of this path done on time, right? We continue to move backwards. 5 plus 15. Task C must be done 20 days to completion. We got here 7 and 8. Task D must be done 15 days prior to completion. Here we have task E. 13 plus 10 is 23. 15 plus 10 is 25. So task E must be done 25 days prior to completion. And then 25 plus 7 is 32 days prior to completion for task A. 25 plus 2 is 27 days prior to completion for task B. So what this tells us is that the shortest time we can complete this task is 32 days, because that is our highest number. So we must start 32 days prior to when we want the project to end. You'll notice this is the same number that we got when we did our critical path analysis as well. Alright. Just to walk you through critical path analysis one more time. This is the same example, so if you understood on Tuesday, you can stop the video. You're good now. But here, right, we go ahead, we add a box to each one of these, and we know we have to fit 2 numbers in that box. So at each vertex, we're just going to put a little box so we can put 2 numbers, right? Then we're going to go ahead, we're going to work our way left to right. And then we're going to work our way back right to left. And that'll give us our earliest and latest times for each of these objects, right? So here, similar idea, right? We just saw backflow works from right to left. Critical path analysis is going to go left to right and then right to left, okay? So here we know that each of these can start immediately from start time plus 0, 0, and 0, right? Now here, task E, I've got 0 plus 7 or 0 plus 2. Remember, I have to take the higher of the 2 numbers as I work to the right with critical path analysis. So 7 plus 2, 0 plus 7 here is higher, so this will be 7 in this box, right? Now I've got 7 plus 10 on both of these. This will be 17. This will be 17. Right? And now here I've got an option at F, right, for which I forgot to draw the box, right? So here at F I've got 17 plus 5, which is 22, or 17 plus 8, which is 25. Again, I'm going to take the higher of the 2, so this is going to be 25. Okay. We also have 17 plus 5 here for this one, which makes this 22. Okay. We have 22 plus 8, which is 30, but we got to wait and see what this path works out to be. 25 plus 2 is 27. 0 plus 15 is 15, so I'm going to take the 27. 27 plus 2 is 29. And then here I've got the option 22 plus 8 is 30. 29 plus 3 is 32. I take the higher number, which is 32. Again, notice you're getting the same number from backflow analysis as you are from critical path analysis, so it doesn't really matter which method you choose unless one's indicated on a problem. But now we want to work backwards, because this is also going to give us kind of our float time on each assignment and help us sequence them, right? So here we've got 32, right? And now we go ahead and work backwards, right? So 32 minus 3 is 29. 32 minus 8 is 24. All right. Then we've got 24 minus 5 is 19. And then going this way, 29 minus 2 is 27. And then 27 minus 2 is 25. So this one, 25. Now as we get here, right, we've got 24 minus 5, which is 19, and we have 25 minus 5, which is 20. Remember, going this way, we're going to take the lower of the two numbers, so this is going to be 19, right? And then down here, we've got 25 minus 8, which is 17. Okay? And then here, 17 minus 10, 19 minus 10, we're going to take the lower of the 2, which is 7. And then 7 minus 7 is 0. 7 minus 2 is 5. And then 27 minus 15 is 12. And then if you recall, my critical path lies along wherever I have the numbers that match, right? So if I take a look here, my critical path, I will start with task A, right? Then I'll go to task E. Then I'll go to task D. Then I'll go to task F. And then here from task F, I'll go down to task I, and then to task J, and then finally to the end of the project. Alright, so critical path analysis and backflow analysis. Alright, go ahead and complete the assignment on Canvas, and feel free to email me if you have questions. Thank you.